This video has been sponsored by Nuage Networks. For more information on the Nuage Virtualized Services platform and how Nuage is delivering consistent policy-driven automation across data centers, the WAN, and branch locations everywhere, please visit nuagenetworks.net and follow us on Twitter at Nuage Networks. We hope you enjoy the session.
After watching this video, visit ipspace.net/sdn to learn more about software-defined networking and overlay virtual networks. Scaling NAT is hard. It's exactly the same thing as scaling load balancing. There is no guarantee of symmetrical paths, particularly as you go from physical to virtual. In best case, you will get some rehashing after the topology change. Worst case, all the state will change after the physical topology. Well, all the traffic flows will be rehashed after the physical topology change. Because we tie the shared state, it has to be tied to the outside IP address. We cannot do much. The state has to be distributed across all members of the NAT cluster. There are solutions that solve this problem in one way or another. Some scale better than others, but maybe we might be solving the wrong problem. Remember, we should always focus on the user needs. In this case, we want to have some virtual machine that is available from the outside, and then we might use something like Amazon Elastic Load Balancing here, which is a totally different story. We're not talking about that here. Or we might use a load balancer on this virtual machine. In any case, we need a one-to-one mapping between what is usually called the floating IP address, and this is a public IP address on the outside, and a private IP address on the inside. This is a one-to-one mapping in most cloud orchestration systems, and there is no state because there is a one-to-one mapping between them. Or some inside VM needs to access the outside resources, the global internet or some external resources. In which case, mostly it's irrelevant what outside source NAT address we use for this, particularly if the VM is accessing the external server. If the VM is accessing a trusted external resource and you want to do source IP address-based validation, then maybe you are yet again solving the wrong problem and you should be using encryption and certificates. Anyway, what Nuage is doing in this case is if you want to do floating IP address from some virtual DRS, which is their acronym for VRF, DRS stands for Distributed Routing System. So this might be a public VRF that's connected to a PE router or a hardware gateway. And you want to have mapping between this outside IP address and a VM IP address, which is sitting in some tenant VRF. A very simple thing is done. A one-to-one NAT rule is created on the hypervisor where the VM sits, because this is a one-to-one mapping between the outside public IP address to the VM private IP address. And then this hypervisor advertises this public IP address to the outside VRF. If the VM sends a packet to another VM or another IP address within the tenant routing system, then obviously the VRS knows where to send the packet, and the packet is sent within the tenant VRF. If, on the other hand, the packet is coming from the outside to the inside, so someone wants to talk with that VM over there, the packet hits the public IP address, which is on the hypervisor. This public IP address is made reachable because the hypervisor is announcing it into the public VDRS. And this one-to-one NAT rule sends the packet to the VM. On the other hand, if the VM is then replying to that, and the traffic is going from inside to outside, because the destination is not reachable inside the tenant address space, and there is a NAT rule for this VM, the hypervisor, the virtual router, would send the packet through the NAT rule to the outside world, apply the NAT transformation, and send the packet to the outside world, where it will eventually be delivered to the client over here. Here's a question for you, Dimitri. Should we anticipate a performance impact when using NAT?
Actually, no, because of the way the vSwitch works, it has a user space and a kernel space, right? So the first packet hits the user space decides that there is NAT that has to happen and installs a regular flow on the kernel space, and the kernel space allows the override of IP addresses, so there is no visible performance impact by doing this distributed NAT.
So we are actually doing NAT in the OVS, and because it's taking the same code path as any other packet forwarding activity, there is no performance impact. And do keep in mind that this NAT rule is totally stateless, and it is only active on one single hypervisor. What if we need to access the outside world from numerous VMs? Well, in that case, what happens is we have this outside VRF, and every hypervisor gets one IP address in this outside VRF. Then whichever VM sends a packet to an unreachable destination, a destination that's not in the tenant routing table, that packet hits the default route that pushes it through to the public VDRS through the NAT rule. And as the packet goes through that NAT rule into the public VDRS, we create the stateful NAT entry in the hypervisor for individual session. The previous solution used a one-to-one NAT entry between the public and the private IP address. Here we need a NAT entry for every session, obviously. This is a classical port address translation. And then the packet is delivered to the outside server. And when the return packet is coming back, it's sent to the IP address of the hypervisor in the public segment. And because the hypervisor already has the reverse mapping, Open vSwitch translates this to the VM IP address, and the packet is delivered to the VM. A question on the previous slide: does one-to-one NAT rule get advertised to VSC? If I understand correctly, it's actually VSC that installs that NAT rule in the hypervisor, but I may be wrong, Dimitri.
That is correct. The VSC is the only control plane component. It's the only one that knows about the control plane of the public VRF and knows about the control plane of the private VRF, and it's the one that installs the routes into the hypervisor. And so it installs all the specific routes, let's say, for the VMs that are known within the tenant network. It installs a default route, or it can install other routes that it learns from the PE. And then if a packet hits these routes, these are the routes that will take the public VRF path and be NATed or source NATed.
Another interesting question: so what happens if the outside to inside return is asymmetric? It cannot be asymmetric because the IP address that is used on the outside is always assigned to a single hypervisor. So regardless of how the packet gets to that hypervisor, eventually it arrives to the hypervisor, and it arrives in the public VDRS, which can be VLAN or an overlay virtual network. In both cases, it arrives to that hypervisor, which has the NAT rule, because the outside IP address belongs to the hypervisor. So you cannot get asymmetrical traffic flows. And the path from the inside to outside is also always performed on that hypervisor. So yet again, there is no way that a VM would send a packet that would traverse inside network and then go out on the wrong hypervisor. Do keep in mind that with this solution, the goal is connectivity and not a specific NAT outside address. Oh, and here we have a curveball question. What happens if the VM moves, like vMotion, to another hypervisor during the communication? Well, if it moves, then the floating IP address moves with it, which means that the one-to-one NAT rule moves, and we don't have a problem. We might lose a packet or a few packets because of the traditional routing protocol convergence. But Dimitri, what happens if we have the distributed outbound port NAT and a VM moves?
In the static NAT case, there is no problem. In the outside NAT, the flow information is not propagated currently, so the flows will have to restart if the VM moves during these flows.
Yeah, there is no way around that. If we want the solution to scale, we cannot have shared state, or at least not too much shared state, in which case, well, yes, we'll drop the session. If you like this video, go to ipspace.net/cloud to explore other overlay virtual networking webinars.